Hey guys, welcome to Lesson 19 Notes. Just wrapping up our little mini unit of transformations. Today we're working with something a little different. With these I can statements, you're going to want to determine whether the steepness of a function has increased or decreased, and that's based on the leading coefficient. So we're going to be looking at steepness today, which is also just another way of saying slope or rate of change. Write a new equation from a given equation that has changed steepness. Alright, so go to your little handy app here, your website, Desmos. Probably not even saying that right. But anyways, we're going to graph these following functions on our graphing device. So 2x is already in here, it's the red line. I'm going to go ahead and put in 5x. We'll compare those two. So 5x is this black line. You see how it is narrower, or we could say it's more steep. So f2, or 5x, is more steep. Alright, so let's look at the next one. So 0.5x. So you can just put it in like 0.5. Don't put in the multiplication, put in x. So that's going to be this red one that's wider, or it's less steep. Less steep. And say that's wider. Okay, so you see point F4 there. You're going to have to do that in a second, but do you see a general trend? We started with 2x. It was kind of like that, and then 5x was it was more steep, so it was kind of like that, and then we had our 0.5x, which is less steep, and it's just like, so it's not got a high rate of change, so therefore it is less steep. So go ahead and finish out F4. How does it compare to F1? So I'm doing it too, and it looks like it is also going to be less steep, or we could say wider. Alright, so good on those. Those are linear functions right there. They all make a straight line. That's all linear means. So moving on down here, it says, what if we add some negative signs? How will this affect the steepness? Well, let's check it out. We still have f of x, f1, the first one. That's all that means. We're just signifying which one's the first one. So still f of x is 2x. So I got that one right there. So let's do negative 2x. So you're going to do that, and then x. Okay? So it's still got the same steepness in comparison to f1. So they're the same steepness, but we'll say f2 of x opens down, while f1 of x opens up. So f1 of x, in other words, is going in a positive direction. We know it's increasing. So let's look at f3. So negative 0.5x. Let's put that in right underneath, right here. Okay, so you see how it's going to be less. So we're comparing it to f1 here. It's a less steep than 2x. And again, it opens down, while f1 of x opens up. Alright, so you know what you're going to have to do. Go ahead and finish the bottom of this part here. How does F4 compare to F1? So you can see my F4 right here, or sorry, right there, it's the black one. So it is, so that's not right. Oh yeah, it is. So it is the black one, and then that's, yeah, so that's why it's more steep. Sorry, I got lost. So yeah, hopefully you said it's more steep and opens down. That's the negative. While F1 of X opens up. So in other words, it's going down. It's decreasing. And then we're saying F1 is going up. Alright, so let's go ahead and flip over here. It wants us to write an equation that is less steep than 5x. So we could pretty much pick, let's just test it out here just to make sure. 5x, let's put that in, and then we could just test this out. I'm pretty sure from what we've seen, anything under 5 is going to give us something less steep. So let's just do well, let's not do 2x, let's just do x. So that's less steep. So let's go ahead and write y equals x. Or of course you could write, we know y stands for f of x, right? Okay, so that's just there's an assumed 1 right there with the rate of change, so that would be like it's going up 1 every time it's going over 1. So we'll get into slope a little bit more here soon, but that's a little review for it. So go ahead and write an equation that is more steep. That's going to be on you. And I'm going to go ahead and move down. So what about steepness of a quadratic function, they're wondering. So let's work with these. We have x squared is f1. Okay, so you see f1 is the red one. So try to keep with red here. And then we have 2x squared. So let's go and do 2x squared. So that's the blue one. You see how it is. How does it compare to F1, you think? Right, I think it's more steep. Or we'd say it's narrower again. Alright, so let's look at, now that we see that one, let's look at this one, 0.5x squared. So 0.5, oh, there's an x right there, I didn't even know that. Okay, so 0.5x squared, and that's our green one. You see how it's the widest one, it's less steep. So it's wider